Okay, in this video we are going to learn how to graph a square root function like this without touching a calculator. Alright, this one's going to be slightly different than the ones we've done before. Normally we start with the parent function, y is equal to the square root of x. But this has this little -1 on the inside of the function, so it's very difficult to isolate just the square root of x. But here's what we can do. Let's graph the function that we would have if we didn't have any addition or subtraction. So basically, see this +1 right here? Imagine that we took that +1 out of the problem. Okay, I'm just taking that out for a second. Alright, so now I just have the square root of -x. This is very similar to the square root of x with all we have to do is figure out how to handle the negative sign. Now, if we were going to graph the parent function y is equal to the square root of x, we would go like this. We'd have our x and our y, and we would use our good old 4 values that we love to graph. We would do 0, 1, 4, and 9, because the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. Now, on the other hand, if we have y is equal to the square root of -x, though, this complicates things a little bit. So we got to be real careful. We'll have to make one change. Now, if I substitute 0 into this equation, then that means I have the square root of -0. Well, that's really just the square root of 0. So that's still 0. So that's not the problem. The problem is the rest of these. If I substitute 1 into this equation, that's the square root of -1. Well, that's imaginary. That's going to be I. And that can't be graphed on this plane. It's imaginary. And similarly, if we put in 4 right here, that'd be -4. And again, that's going to be imaginary. That's going to be 2i. And if I put in 9, that'd be -9. That would be 3i. All of these are imaginary. Alright, we can't graph this on a regular coordinate plane. So can anybody imagine what it would take to fix this so that we're not getting imaginary numbers? How about instead of using 1, 4, and 9, what if we simply used -1, -4, and -9? Would that solve the problem? Let's take a very close look at it. Okay, so we've already established that 0 is not a problem because the square root of -0 is still just 0. Now, what if I put -1 into this equation? Can you see I'm going to have two negative signs? I've got this negative sign, and then I've got the x value. So it's sort of like I've got this. I've got the square root of -x. I've got the square root of -x. Now my x values are -1 and -4 and -9. Now by putting this extra negative in there, now I have -1, or the opposite of -1. And you've probably figured this out by now, but the opposite of -1 is +1. So we're back to this again. So the square root of -4 is the same thing as the square root of +4. The square root of, and I don't actually say -9, I say the opposite of -9, and that is actually going to be the square root of +9. So of course this is going to give us 1. The square root of 4 is 2, and the square root of 9 is 3. Alright, so by making that one small change of using these negative x values, then that will cancel out the negative that's already there and turn them positive and give us normal values that we can use. Now notice, still I have covered up the addition or subtraction, whatever was under there. I think it was addition. So this will not be the final answer when I graph it, but that's okay. So this is the skeleton. So my skeleton is going to be 0, 0, and then negative 1, 1. So here's negative 1, 1. Negative 4, 2. And negative 9, 3. So here's negative 9, comma 3. All right, there's my skeleton. Okay, now let's uncover this addition or subtraction. All right, plus 1. Now let us remember what putting a plus 1 on the inside actually does. Can you remember that a plus 1 on the inside takes us to the left 1? Okay, that's what a plus 1 does underneath the radical. So that means I'm going to take each one of these points and I'm going to move it to the left one. So this is going to end up here. This will end up here and here and here. I just moved everything left 1. And I'll go ahead and connect that because that will be my final answer. Okay, that's not the smoothest curve in the world, but whoa, okay, well, fate intervened and erased my ugly drawing, giving me a chance to do better. Okay, let's see if that disappears. Well, okay. I don't know why this keeps disappearing. I'm only going to draw it one more time before I give up. Will it stick around? Okay, I don't know why this is disappearing. I'm just going to ignore that for right now because, yeah, I could be doing this all night. But that's what the graph was supposed to look like. And now we can get on into the domain and range. You know what? I need this graph, so I'm going to work on that off camera. So the domain is read from left to right. So this graph goes to the left forever. So that's going to be negative infinity. And to the right, it goes until negative 1. So negative infinity to negative 1. That's the domain. The range is read from bottom to top. The lowest point on this graph is here at a y value of 0. And then it goes up from there. So 0 and up, 0 to infinity. All right, that is it for problem number 4.